Hi guys, today we're going to talk about isosceles and equilateral triangles. This is the last lesson that we are going to do in chapter 4. Our focus is on, of course, isosceles and equilateral triangles. Hopefully you've heard some of this information before, but some of it will be new as well. If you take a look at an isosceles triangle, we have discussed some of its parts before. For example, we've discussed the vertex angle, which is the angle that holds together the two congruent sides. If you take a look at this triangle, let's call it triangle ABC, then the vertex angle would be angle B because it holds together the marked congruent sides. The sides that are the same length are called the legs of the isosceles triangle, and the one side that's a different length is called the base. The base does not necessarily have to be the bottom of the triangle, it's just the side that's different from the other two. In an isosceles triangle, we also have two base angles. The base angles are the two angles connected to each end of the base. And in an isosceles triangle, the base angles are always congruent. So here I know that angle A and angle C are the base angles, and they are always going to have the same measure. We know that that's true because of the isosceles triangle theorem. The isosceles triangle theorem says if two sides of a triangle are congruent, then the angles opposite or across from those sides must be congruent. So if we refer back to our first picture, across from side BC is angle A, across from side AB is angle C. Since AB is congruent to BC, the angles across from them, angle A and angle C, must be congruent. The converse to the isosceles triangle theorem holds true as well. If I have a triangle where I know that two angles are congruent, then the sides across from them must be congruent. Using those two ideas, let's answer the first couple of questions. So in question number 1, it says, if I take a look at the figure, if side AD is congruent to side AH, we have to name the two congruent angles. So based on these two sides, we're going to focus on the entire picture, triangle ADH. Directly across from side AD is angle DHA. Across from side AH is angle ADH. So they are what are called the base angles, which means they must be congruent. For question number 2, we're going to use the same picture, but this time we're given different starting information. In question number 2, we have if angle BDH. So now we're just within this medium-sized triangle is congruent to angle BHD. Our job is to name the two congruent segments. So if I focus in on this medium-sized triangle, the converse to the isosceles triangle theorem says across from these congruent angles are congruent sides. Across from angle H would be side BD, and across from angle D is side BH. They are the legs of this isosceles triangle and therefore must be congruent. In questions 3, 4, and 5, we are given equilateral triangle EFG. So remember, equilateral triangles are a special type of isosceles triangle where all three sides must be congruent. Based on the isosceles triangle theorem, not only are all three sides congruent, but all three angles must also be congruent. We've discussed before that in an equilateral triangle, every angle measures 60 degrees. That's because if we take the 180 degrees of the triangle, split it evenly among those three, 180 divided by 3 gives us 60. We're also told in this question that line segment EH bisects angle E. So up at the top here, we know that this large angle gets cut into two congruent parts. And our job is to find some of the different measures. So if I take a look at questions 3 and 4, angle 1 and 2, we just marked congruent. We know that together, angles 1 and 2 are 60 degrees. So if it's bisected or cut in half, that means that each half must be 30 degrees. In order to find x, we have to focus in on just one of the smaller triangles in this figure. So 15x represents the measure of angle FHE. If I look inside of just that little triangle, its three angles are 30 degrees, 60 degrees, and 15x degrees. Remember that the angle sum theorem tells us that the three angles of a triangle must add up to 180. So 15x plus 30 plus 60 must equal 180. Therefore, 15x equals 90, and x should be 6. Question number 6 also deals with an equilateral triangle and its angle measures. It says triangle GHF is equilateral, and then we're given algebraic expressions for each of its three angles. So remember, every equilateral triangle is also equiangular, and each of these angles must measure 60 degrees. So in order to solve for x, y, and z, we're going to create three separate equations. The first one will say that angle F, which is 3x plus 4, must equal 60 degrees. The second one, angle G, which is represented by 6y, must also equal 60 degrees. And last, angle H, 19z plus 3, must also equal 60. When you solve these three equations, you should get that x is 18 2/3, y is 10, and z is 3. Okay, when you flip over to the back, we're going to deal with angle measures within several different triangles. So these look familiar to some of the problems we did at the beginning of chapter 4, where you sort of have to work your way around the picture in order to find different measures. For the time being, I'm not going to pay attention to the questions. I'm just going to figure out any angle measures in the picture that I can. When you look at this figure, the letter F down at the bottom here got cut off a little bit. So just so you know, this should be the letter F. Okay, so it says triangle ABF is isosceles. So if triangle ABF is isosceles, and I have the two sides that are marked congruent, I automatically know that its two base angles, which are angle A and angle BFA, must be congruent. Then it says triangle CDF is equilateral. So in every equilateral triangle, we know that each of the angles measures 60 degrees. And we're also told that the measure of angle AFD is 150 degrees. So AFD, all of this, is 150 degrees. Okay, if I take a look at this picture, one of the first angles that I'm going to find is angle BFA. So if angle AFD is 150, but I've already used up 60 degrees for this part of the angle and 35 degrees for this part of the angle, 150 minus 60 minus 35 makes this angle 55 degrees. If the base angle there is 55 degrees, then the other base angle, which is angle A, must be the same, is also 55 degrees. And then if I focus in on triangle ABF on the left side here, it has a total of 180 degrees. We've already used up 55 and 55. So 180 minus 55 means that we have 70 degrees left for angle ABF. I believe we have enough information to answer all the actual questions. So now using our picture, for number 7, the measure of angle CFD was 60 degrees. The measure of angle AFB was 55 degrees. Angle ABF is the vertex angle of our isosceles triangle. That one was 70 degrees. And angle A was a base angle of that same isosceles triangle and measures 55 degrees. Okay, last but not least, we're going to go through a proof that involves both isosceles and equilateral triangles. Obviously, you can see this one's going to be pretty long, but in our given, it says, triangle CTE is an isosceles triangle with the vertex angle C. The measure of angle T is 60, and our job is to show that this triangle is also equilateral. So from our given information, if I have an isosceles triangle and I know the vertex angle, then that means I know which two sides must be congruent. So if our vertex angle is angle C, it holds together the two congruent sides, which means that CT and CE must be congruent. That's by our definition of isosceles. Once I know that those two sides are congruent, the isosceles triangle theorem tells me that if I have two congruent sides in a triangle, then the angles opposite them must be congruent. Those are the base angles, which in this picture are angles T and E. So for my third statement, I'm going to say angle T must be congruent to angle E. If angles T and E are congruent, then we know that means that they have the same measure. So the measure of angle T equals the measure of angle E by the definition of congruent. And I'm changing these into equal measures because I'm anticipating using different algebraic operations on an equation. And this actually is a good time to come up with an equation. So we have that angle T and angle E are equal. We also know that angle T is 60 degrees. I need to figure out that the triangle is equilateral, but I know that if I could show the triangle is equiangular, then I could also say it's equilateral. So I'm going to focus in on the three angles of the triangle. I know that if I add up these three angles, angle C, angle T, and angle E, they must have a sum of 180 degrees. That's because of our angle sum theorem. Once I create that equation, I'm then going to substitute some of the different measures. So for example, I know from the given that angle T measures 60 degrees. So I'm going to plug that in. I also know that angle T and E are equal from step number 4. So I can change this to angle T as well. Using substitution another time would allow me to say that this angle T is also, of course, 60 degrees. So first I have the measure of angle C plus 60 plus the measure of angle T equals 180. When I plug in 60 again for the second angle T, that gives me that the measure of angle C plus 60 equals 180. Both of those steps are substitution. If I take the equation from step number 7 and I subtract off the 60 degrees and the other 60 degrees from both sides of the equation, I can find that angle C also measures 60 degrees. Now that I have angle T, angle E, and angle C all equal 60 degrees, they must all equal each other. So then I'm going to make a statement that says the measure of angle C is equal to the measure of angle T, which is equal to the measure of angle E. That's substitution. Of course, if their measures are equal, that means that those three angles must be the angles of an equiangular triangle. Before we can say that, however, we have to show that they are congruent. So I have angle C is now congruent to angle T, is congruent to angle E by our definition of congruent. And now we can say our triangle CTE is equiangular That's because of the definition of equiangular, means all of the angles are the same size or congruent. And we know that every equiangular triangle must also be equilateral. So that gives us our very last step. And our final reason is going to say all equiangular triangles are equilateral. We're just going to write out the sentence for that one. Have a great day, guys.